Hello friends. So this is a very important topic which we have taken, that is applications of derivatives. Now this is a topic for class 12 and this is a very important topic because we deal with problems which tell us what are the applications of derivatives, right? So in the previous chapter you have studied a number of formulas, you have gone through a number of formulas and you would have solved a lot of problems on derivatives. Now, but where is derivatives used? Where can it be applied? So this is what this chapter talks about. So when we try to list out all the various applications of derivatives, they actually fall under 5 categories, right? So derivatives can actually be used to find the rate of change of quantities. For example, how fast the object is moving with respect to time. So derivatives are actually used to find the rate of change of quantities, right? So rate of change of distance with respect to time, right? So rate of change of any quantity x with respect to another quantity y. Now how do I do that? How do I find that? That can be done by using derivatives. Okay, so therefore derivatives are actually used to find the rate of change of quantities, right? So we will be solving a number of problems where we'll be finding the rate of change of various quantities, which we should be doing in the first exercise. Next, derivatives can also be used to find the equations of tangents of normal to a curve at a given point, right? So suppose I have a curve. Can I find the equation of a tangent or can I find the equation of a normal? So normal is perpendicular to the given curve at a given point, say x comma y. So is it possible for us to find those equations of a tangent or the equations which are normal to a curve at a given point x comma y? So yes, we can find that. Next, we can also find the turning points. So what do you mean by turning points? Suppose I have a graph, right? So therefore, let's assume that this is variation of temperature. Okay? So therefore, here I find that the temperature has reached maximum and then it has decreased, and somewhere here it has reached a minimum, and this is, say, in a duration of, say, 24 hours. So in a duration of 24 hours, I find that this is the maximum and this is the minimum. Okay, so that essentially indicates the turning points, or it can be pressure, or it can be the speed of a given object. So how do I find these turning points of a given function on a graph which actually indicates the largest or the smallest value? So this will indicate the largest or the smallest value. So can we find that? Yes, it is possible by using derivatives. Now we can also find whether a function is increasing or decreasing. So I have a function like this, it is increasing. Let's assume that there is a function which is going like this. This is a decreasing function. Or there may be a function which remains constant. Can we find whether a function is increasing? Can we find whether a function is decreasing? So that mathematical equation can actually represent a physical quantity, right? So therefore, we can actually use the derivatives to find whether functions are increasing or decreasing. And they can also be used to find the approximate values of various quantities, right? So based on all these 5 categories, we should be solving problems. Okay, so there's almost an exercise on each of these 5 different categories of applications of derivatives. So the first exercise deals with the rate of change of quantities. So here in this lecture session, we shall go through all the problems given in the example. We shall go through all the worked examples, and based on the worked examples, in the next video segment we shall solve all the problems given in the first exercise. Now let me tell you that this chapter is very important and this chapter is very interesting too, right? So now let's begin with how we can use the principles of derivatives to find the rate of change of quantities. So let's begin with the first example. First example states that find the rate of change of area of a circle with respect to its radius r when r equals 5 centimeters. Now such problems are very simple, right? So first, what is being given in the problem, let us just check. So we need to find the rate of change of area of a circle. So we know that area of a circle is given by pi r square. So I need to find the rate of change of area of a circle with respect to its radius. Okay, so here the quantity is area with respect to the radius of a given circle. So now let us perform dA by dr. So pi is a constant, so it is pi into 2r. So I need to find the rate of change of area with respect to the radius when the radius r equals 5 centimeters. So here I put the value of 5 here, so it becomes 10 pi. So therefore when I substitute the value of r here, it becomes 10 pi centimeters square per second. So this is the rate of change of area with respect to the radius r. Okay, so now the second problem states that the volume of a cube is increasing at the rate of 9 cubic centimeters per second. How fast is the surface area increasing when the length of the edge is 10 centimeters? Okay, so the volume of the cube is increasing at this rate, and we need to find how fast the surface area is increasing when the length equals 10 centimeters. So the cube is actually increasing here. So let the side of the cube, so this is a cube, so let the side of the cube be x, okay, and let V be the volume of the cube and S be the surface area here, right? So what is being given here? Of course we know the volume is x cube, right, because it's been given that we have the volume of a cube. So in a cube all the sides are equal, so we have assumed that the side of a given cube is x, so volume is x cube. And what about the surface area, right? So the area of one side is x square, but we have 6 sides, so it's going to be 6x square. Okay, so now what has been given? It has been given that the volume of the cube is increasing at the rate of 9 cubic centimeters per second. So it has been given that dV by dt is equal to 9 centimeter cube per second. So the rate of change of volume is given, which is dV by dt. So now let me perform dV by dt. So dV by dt is 3x square. So it is dV by dt is 3x square into dx by dt, right? So we know the chain rule here, so it is going to be dV by dx into dx by dt, which is nothing but dV by dt here. Okay, so I differentiate x cube with respect to x and x with respect to t, so I get 3x square dx by dt. So next, it's been given that the surface, of course we know that what is S? S is the surface area. So S is 6x square. So let's define the rate of change of ds with respect to t, right? So here you have 6 into 2x dx by dt. So here I get 12x dx by dt. So that is what has been given there. So now we know that dV by dt is 9. So I can substitute 9 here. So in equation 1 I can substitute dV by dt equal to 9. So therefore, so dV by dt is 9 equal to 3x square dx by dt. So what is dx by dt? So 3, so I get 3 by x square. So dx by dt is 3x square. So what do I need to find? I have to find how fast the surface area is increasing. I need to find ds by dt. But I know that dx by dt is 3x square. So ds by dt equals 12x. So dx by dt is 3x square. So I'll substitute this here, 3 by x square. So x gets cancelled. So now what do I have? I have 12 into 3 is 36 by x. Right? So now what about x when the length is 10 centimeters? Okay, so I've considered the length, that is the side of the cube equal to 10 centimeters. So therefore, when it is 10, it is 3.6 centimeter square per second. Right? So here, a few things have been given. So the volume, the surface area of a cube, it's been given that dV by dt is 9 centimeter cube per second. So we get this expression. So similarly, we also know the formula of the surface area of a cube, which is nothing but 6x square. So differentiate this. Now dV by dt has been given. So substitute the value of 9 here and you get dx by dt. Substitute the value of dx by dt in the expression ds by dt. And we need to find the rate of change of the surface area of a cube when the length, that is the side of the cube, is 10. Right? So x is 10. So 36 by 10 gives me 3.6 centimeters square per second. So a very simple problem. So let's move on with the third problem. We have a problem where it's been given that a stone is dropped into a lake. So a stone is dropped into a lake. So when a stone is dropped, what happens? The waves move circularly. Right? So you know that when you drop a stone into a pond or into a lake, we find that waves move in circles. So waves move in circles at the speed of 4 centimeter per second. Right? So the waves are moving. So what do you mean by saying that the waves are moving? They move along the radial distance of the circle. So therefore, dr by dt equals 4 centimeter per second. Right? So the circles are moving. So the radius of the circle is becoming bigger and bigger, and it is moving at the rate of 4 centimeter per second. Now we need to find the rate of change of the area enclosed. So how fast is the area increasing? So area is given by pi r square. So I need to find out how fast the area is increasing, which is dA by dt. When the radius is equal to 10 centimeters. So let me do dA by dt. So dA by dt equals pi into 2r dr by dt. So it has been given in the problem that dr by dt is 4. So let me substitute that here. So I get pi into 2 into r into 4. Also, r is equal to 10. So I need to find dA by dt when r equals 10. So therefore I get, so this is 8 into 10, which is 80 pi centimeter square per second. Right? So the rate of change of area is nothing but 8 pi centimeter squares per second. Okay? So now we also need to remember that dy by dx is increasing, then it's going to be positive, whereas the rate of change of y with respect to x is decreasing, then it becomes negative. Okay? So we'll be using this concept in the next problem, in problem 4. It's been given that the length x of, say, a rectangle is decreasing at the rate of 3 centimeter per minute. Okay? So therefore, the length x is decreasing. So I have dx by dt, which is equal to minus 3 centimeter per minute. So the length is decreasing. Right? So therefore, I use a minus sign here. But whereas the width y is increasing at the rate of, so this is increasing, y is increasing, it is increasing at the rate of 2 centimeter per minute. So dy by dt equals plus 2 centimeter per minute. So this has been given. So you have x and y of a rectangle, right? So the length is decreasing and the width is increasing. So I have a minus sign here and I have a plus sign here. So next, what has been given? Find the rate of change of perimeter, and we also need to find the area of the rectangle when x is 10 centimeters and y is 6 centimeters. Okay, so now how do I find the perimeter? The perimeter is, so this is, let's assume that this is x and this is y. So the perimeter is 2x plus 2y. So it is 2 into x plus y. So I need to find the rate of change of p. So this implies dp by dt is 2 dx by dt plus dy by dt. Now what is dx by dt? Dx by dt is minus 3, we know that, right? So the length is decreasing. So it is 2 into minus 3, dy by dt is 2. So I get minus 2, right, centimeter per minute. So what is happening? The perimeter of the rectangle is itself decreasing at the rate of minus 2 centimeter per minute. Okay, so if the length decreases by 3 and if the width increases by 2, of course the perimeter decreases by 2 centimeters per minute. Now what about the area? Now the area is given by x into y. So what is dA by dt? It is nothing but x into differential of y plus y into differential of x with respect to t. And I need to find the value of the area when x is 10 and y is 6. So x is 10, right? And what is dy by dt? It is 2. Plus, what is y? Y is 6. And what is dx by dt? Minus 3. So we get 20 minus 18. Alright, so we get 2 centimeter square per minute. So in effective, what happens? The area is actually increasing at the rate of 2 centimeters square per minute. Okay, so we have to keep this in mind, that if the differential is increasing, it is positive. If the differential dy by dx is decreasing, then it is negative. So examples 5 and 6 are very easy. The total cost C of x in rupees associated with the production of x units is actually given by C of x. So what is C of x equal to? It is 0.005 x cube minus 0.02 x square plus 30x plus 5000. Right? Find the marginal cost when 3 units are produced. So 3 units are produced, where by marginal cost we mean the instantaneous rate of change of the total cost at any level of output. Right? So what does this mean? So we have the marginal cost MC, which is nothing but dc of x by dx. Okay, so I just differentiate this and substitute the value of x equal to 3 to get dcx by dx, the marginal cost. So now this is 0.005 into 3x square minus 0.02 into 2x plus 30 plus of course 0 here. Okay, so now we put the value of x equal to 3 in this equation. So what do I get? So I get 0.135. So here I get 0.135 minus 0.12 plus 30. Right? So I put the value of x equal to 3. So this would be 0.005 into 3 into 9 minus 0.02 into 2 into 3 plus 30. So that would effectively give me rupees 30.015. Right? So this completes problem 5. So the next problem, problem 6. The total revenue in rupees received from the sale of x units of a product is, so r of x is 3x square plus 33x plus 5. So we need to find the marginal revenue when x is equal to 5. Okay, so of course the marginal revenue is obtained by differentiating r of x with x. So I get 3 into 2x, which is 6x plus 36. Okay, so now of course we need to put the value of x equal to 5. So I get 6 into 5 is 30 plus 36 is 66. So I have rupees 66, which is the answer. Okay, so with this we have solved all the examples given in the textbook, and in the next video segment we shall solve all the problems given in the first exercise of applications of derivatives. So you have seen that how important and how interesting this chapter is. So here in the first exercise, as we have already mentioned, there are 5 different main applications of derivatives. So we should see the rate of change of quantities, and we have seen that when we went through all the 6 examples, right? So we should solve some more interesting problems which are given in the first exercise, and do not forget to like, share and subscribe and press the bell icon to get notifications of further uploads. So make sure that you also join the Telegram group which is present in the description there. So make sure that you join to get the notifications of all the videos uploaded on Maths 12